Welcome to educator.com. This lesson is about length in the coordinate plane. In this lesson, you're going to learn to find lengths of line segments in the coordinate plane. Applications are to use grids to map locations and find distances between them. Vocabulary is a review. X-coordinate is the position to the left or right of the y-axis, so moving left or right. And the y-coordinate is the position above or below the x-axis, moving up or down. And a reminder, the Pythagorean theorem, a squared plus b squared equals c squared. And you would use this with right triangles. Right triangle meaning a triangle that includes a 90-degree angle, has a leg of A, another leg of B, and a hypotenuse of C. And when you square one leg and add it to the square of the other leg, you get the square of the hypotenuse, which is always the longest side and across from the 90-degree angle. Find lengths of line segments. Find the length of the horizontal line segment with endpoints A at -4, 2 and B at 3, 2. Find the distance of the x-coordinates. So first I'm going to graph it. Once you get used to finding the lengths, you no longer will need to graph, but I'll first graph it just to show you the representation. So we have points at -4, 2 and at 3, 2. So once again, it's helpful to use graph paper. Make sure you label your x and your y-axis. So point A at -4, 2. 1, 2, 3, 4, to the left 4, and up 2. That's going to be A. And next is B, +3 over 3 and up 2, B. So we can see that they're on the same line, this line segment here. And we want to find the distance. So the way that we do this is just by finding how far the x-coordinate is, because there is no movement up and down. Once you're on this line, you stay on this line straight across. You don't go up or down. You just go straight across. So B is at 3. So from here to here is 3. And A is to -4. So from here to here is 4. So the distance is from 4 to 0, or -4 to 0 is 4, and from 0 to 3 is 3. So the distance between A and B is 7 units. We don't know which units, so you could say just 7 units. And the way that we would find this would be the beginning point, 3, minus the second point, which is -4. The negative and the negative become a positive, which is 7. Another way that you could do this is to say the beginning point, -4, and subtract 3. But in this case, you need to remember, since you end up with a -7, that distance is not measured in negative values. You wouldn't say that you drove -5 miles, so or -7 miles in this case. So it's always the absolute value. Remember, the absolute value represents a distance. So the absolute value of 7 is still the +7, and the absolute value of -7 in this case giving us the distance of 7. So whichever point you want to start at, beginning with A to B or backwards B to A, you will always come up with the distance of 7 units. Let's continue finding more lengths of line segments. Find the length of the vertical line segment with endpoints C, -3, 4, and D, -3, -2. So I'm going to go back and draw my coordinate plane. X, remember to label it, and Y. It's a little crooked, so it's always nice to use graph paper if you have it for yourself. Okay, so C is our starting point at -3, 4. So I'm going to go to the left 3 and up 4. And that's C. And then D is -3 and down 2. And that's D. And so here's our line segment. And we have not moved to left or right. In fact, it's just gone from C down to D. So let's find the distance from C to D. To go from C to 0, is a distance of 4. And then to go from 0 down to D is a distance of 2. So 4 plus 2 is 6. So if you were going to count the little squares moving from C down to D, you would have 6. Now let's do it with the numbers. Notice that we're not thinking about the x value because we haven't been moving forwards or backwards on the x. It's only been the y. So let's take C and subtract the D value. And that becomes a positive, so it's 6. If you wanted to start a D and go up to C, you would have -2 minus 4 is -6. And remember that distance is not expressed in negative values, so you would find the absolute value, which is +6. So either way, you get 6 units. If it's difficult for you to understand subtracting the C and the D, you can always draw your picture and count the units. Finding distance in the coordinate plane. Find the length of the hypotenuse of a right triangle with legs of length 6 feet and 7 feet to the nearest feet. Okay, so if I have a right triangle and I have 6 feet for leg and 7 feet here, I'm looking for the hypotenuse, the distance here. So we're going to do a squared plus b squared equals c squared. This is c. So a squared would be 6 squared plus b squared 7 squared equals c squared. You can interchange the 6 and the 7, switching them, because the legs really don't matter in the position. And remember that order doesn't matter when you're doing addition. So we have 36 plus 49 equals c squared. 49 plus 36, 15, 4, 7, and one more makes 8. So make sure that you know that C is not 85. That would be way too large compared to 6 and 7 feet. Remember that we still need to find the square root. So C squared equals 85. So in that sense, C equals the square root of 85. There is no exact value, so you can estimate here. And it tells us to go to the nearest foot. So 81 would be closest. And C is approximately 9. And if we come back here and we say that C is 9 feet, that makes sense. The hypotenuse is the longest and 9 is larger than 6 and 7. An archaeologist finds an arrowhead 3 miles south of a fire pit and a bone tool 5 miles west of the same fire pit. To the nearest meter, what is the distance between the arrowhead and the bone tool? So I'm going to draw a coordinate plane. It's a little crooked here. Let's try that again. Okay, here's my x and here's my y. This is going to be north, south, this is east, and this is west. All right, so this says 3 miles south. So let's go. Each of these lines represents a mile. And it's 3 miles south, so 1, 2, 3. I'm calling the origin, the beginning point, the fire pit. It's going to be 0, 0, our starting point. And a bone tool 5 miles west. So here's the fire pit and 5 to the west. 1, 2, 3, 4, 5. So notice here, if I connect these with the original fire pit, I've created a 90-degree and a right triangle. And we know that this is 3 and this is 5. So I'm going to extract that triangle and draw it here. A little bit bigger so you can see it. So we have 5 and 3. So we have our 2 legs. One leg is 3 and one leg is 5. Let's go back to our starting point of Pythagorean theorem. A squared plus b squared equals c squared. So a squared we could call 5. So 5 squared plus b squared we could call 3 equals c squared. 25 plus 9 equals c squared. And that's going to be 34 equals c squared. And we're finding to the nearest meter, so there is no exact square root of 34, but the closest we could say 6 times 6 is 36, and 5 times 5 is 25. So 25 is too small, so let's use 36. So c is about, when you find the square root of 34, c is about 6. And that would work out. It would make sense. The hypotenuse should be the longest, and 6 is longer than 5 and 3. So from that arrowhead to the bone tool was a distance of about 6 meters. Find the length of the line segment with the given endpoints. Okay, first I'm going to draw my coordinate graph, always label X and Y. And let's put in some lines here. Try to make them as evenly spaced as possible. Mine aren't the greatest, but they're close enough. All right, A is at -5. So to the left 5, 1, 2, 3, 4, 5, and down 1. So here's A. And B is at 3, +3, 1, 2, 3, and up 1. All right, so we have approximately from here to here. Okay, well, if you notice, in this case, we've created the diagonal. So let's go back and create our right triangle. So this is the diagonal in the red that's given to us. And I'm going to come down and create a right triangle. So those are the two lines that I've created. These are the legs of the right triangle. They're going to help me to be able to estimate the distance from A to B. Because unlike straight lines, we can't just count the squares across. We need to use the formula to estimate the diagonal from A to B. But now I can count how many units from A over to lining up with B here. We could call this point C. So from here I have 1, 2, 3, 4, 5, 6, 7, 8. So 8 across the bottom. And to go up to B from C, we have 1, 2, 3, 3. So I'm going to extract that triangle, and it looks like this, pretty much. 8 here and 3 here. And I'm looking for C. So the Pythagorean theorem, a squared plus b squared equals c squared. So let's use 8 as A, and b is going to be 3. 64 plus 9 equals c squared. 64 plus 9 is 73, c squared. Let's find the square root of 73. And c is approximately, what's our closest value there? 8 times 8 is 64, and then 9 times 9 jumps up to 81. So I would say that 8 is our closest. So it's about 8. But you know, here one of our legs is 8. So maybe we could try a number a little bit larger, because we want to make sure that our hypotenuse is represented as a larger number. So I'm going to try multiplying 8.5 times 8.5 and see what I get. 5 times 5 is 2, 42, hold the place, 40, 64, 68, 5, 2, 12, 72, 25. So, oh, that's very close to 73. So we can say that C is approximately 8.5. So in this case, it's easy to see that the hypotenuse is indeed larger than 8. And of course 3. So our hypotenuse is the longest. So in a recap, what we did here was sometimes you can find the distance between two points if they're on the same line. They're both on the same vertical line or both on the same horizontal line. In this case, A and B were not on the same horizontal or on the same vertical, so they created a diagonal. And we use that diagonal to represent the hypotenuse of a right triangle, and we created our own legs. And then we're able to find the length of the legs and plug it into the Pythagorean theorem. These problems can be difficult to understand if you don't first draw them on a coordinate plane. So I would always suggest starting off with the coordinate plane. Find the length of the line segment with the given endpoints A, -1, 2, and B, -1, -4. So I'm going to draw my coordinate plane, X and Y. Looking ahead, I see that my numbers are small, so I'm not going to have to draw very many lines here. Okay, A is at -1 to the left 1 and up 2. There's A. And B is at -1 and down 4, B. Well, unlike the last example, these 2 points fall on the same vertical line. So that means that I only have to consider how far above the x-axis and how far below the x-axis it goes. I don't have to think about moving left or right. So this is 2 above the x-axis and this is 4 below. So 4 plus 2 is 6. And if we wanted to use the formula, we could say 2 minus a -4 equals 6. The double negative here becomes a positive. And that's moving from A down to B. If you want to go from B up to A, you could say -4 minus 2 is -6. Remembering that distance is always a positive value, so we find absolute value of -6, so 6. And it doesn't tell us the units, so we'll just say 6 units, a generic units. Your school is 5 miles south of your house. The arcade is 3 miles east of your house. To the nearest mile, how far is your school from the arcade? So let's start off with our coordinate grid here. X, Y, and in this case, I'm going to call this east, this is west, this is north, and this is south. All right, so our house is the origin, the starting point, and that's going to be 0, 0. Next, the arcade is 3 miles east. So 1, 2, 3. So let's go to the right 3 miles east. And it's not saying up or down, so we're just at 3, 0. Next and then the school is 5 miles south. So school is 5 miles south, arcade is 3 miles east. So let's go back to the house, the starting point, the origin, and go 5 miles south. 1, 2, 3, 4, 5. And that is at 0, -5. So south moving downwards, -5. So if you connect these 3 points, you see that we've created a right triangle. So I'm going to extract the right triangle so you can see it a little better. And what we have here is the right angle. And the leg here is 3 because we went 3 miles east. And this leg down here is 5 because we went 5 miles south. And this can be C. So going to Pythagorean theorem, a squared plus b squared equals c squared. So A we'll call 3 squared, and B we'll call 5 equals c squared. And that's 9 plus 25 equals c squared. 9 plus 25 is 34. And we want to find the square root, so we can get just the c by itself. And it's about 6 times 6 is 36. So I would say c is about 6. And if we come back, it says to the nearest mile. So it's fine that we're estimating there. And we're going to say c is about 6 miles. So how far is the school from the arcade? The school from the arcade, this diagonal here, is about 6 miles. Thank you for watching educator.com.